In this video, we're asked to investigate the series n goes from 0 to infinity of negative 3 to the n over n factorial, and we're asked to show this converges absolutely. Then we're asked to actually compute the sum of the series in exact form by comparing to the standard power series for e to the x. So it's not often that we're actually able to compute the sum of a series explicitly, but this is one case where we can. So let's get started with that absolute convergence proof. And to test for absolute convergence, we're just testing the absolute values of all the terms. In other words, the minus sign just goes away. So we're looking at the series 3 to the n over n factorial and trying to figure out if it converges or not. And for this, we're going to use the ratio test. And in the ratio test, we look at the limit as n goes to infinity of the next term divided by the previous term. And sometimes there's absolute value bars written around this, but we're already looking at all positive terms, so I don't need them. And if this limit comes out to a number less than 1, then we have absolute convergence of our series. Greater than 1, our series diverges. Equal to 1, our ratio test is inconclusive. So we go ahead and write down the limit. And an plus 1 is 3 to the n plus 1 over n plus 1 factorial. Then I'm going to divide by an, in other words, the terms I'm just looking at in the series. And when I divide by that, I multiply by the reciprocal, so that's n factorial over 3 to the n. Now I start to manipulate this limit to cancel as many things as I possibly can. So I'm going to split off a 3 from that first term, and that gives me a 3 times 3 to the n. And then the n plus 1 factorial, I can expand that as n plus 1, just splitting off the first term, times n factorial. And now I can see that my 3 to the n's cancel and my n factorials cancel. And now I'm left with an unambiguous limit. 3 over n plus 1 as n goes to infinity. That's a constant divided by a term that's going to infinity. So this comes out to 0. And I can conclude that my original series is absolutely convergent. And that also implies that the alternating series itself is convergent. So next we get into this kind of bonus question where we can actually find the sum of this thing by comparison to e to the x. So a quick reminder of the standard power series for e to the x. And I'll post a video real quick to where this was first derived. So as it turned out, by computing a Maclaurin series, e to the x can be written as the sum as n goes from 0 to infinity of x to the n over n factorial. And then when I compare to the series that we started with, I realize I have some number to the n over n factorial, and n is going from 0 to infinity. So x is just negative 3 here. So I have e to the negative 3. Just to make this extra clear, e to the negative 3 is going to be negative 3 to the n over n factorial. In other words, the sum of our original series is equal to 1 over e cubed. And we're done. If you find the math content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce dozens of new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.